Hello friends, welcome to follow up. Let's have a look at today's daily challenge problem. Problem 445. Add two numbers 2. In this video, we're going to first get the number the linked list represents, and then we add them together and we output it into a linked list format. So actually for this problem, so if the height representing the least significant digits, we can directly add them together. So in other words, if we reverse the linked list, and then we can add them together without transforming the linked list to be an integer it represents. Both actually very easy to implement. Actually, this problem add two numbers if the numbers are represented by a linked list. The problems or related ones are very classic. So here we are giving two linked lists, right? Then we want to find their sum, and then we output in a linked list format. So here is the constraint. First, the number of nodes in each linked list is in the range given by the closed interval 1 and 100. So this actually means that each of the two linked lists is not very long. And secondly, so the node represents a digit, right? And also it's guaranteed that the list represents a number that does not have leading zeros. So if there's a leading zero, the number can only be 0 itself, right? As here. So here, there's also a follow-up. Could you solve it without reversing the input list? So here, if we are taking a way which we feel that is a little bit cheating, but it does not using the reverse. So here, I'm going to first write a method. Basically, we transform a linked list into a digit number, or in a numerical number or integer. So here's get number. So we have a height, right? So we're going to get the number it represents. So here we initialize a result variable, and we want to find its final state and return. So we are going to set current to be height, right? And then we're going to check well current. So we're going to update the result by the following: result equals the previous one times 10 plus the current value. And then we're going to reset current to be current next. So this way we are going to get the result. So let's give a height, so we get the corresponding number, right? So in the main function, so we can get the two numbers represented by the two linked lists. So self get numbers. So height 1, and then let's copy this part. So we are going to change this one to be height 2. And then we are going to set n equals n1 plus n2, right? And then for convenience, we can use integer division. Each time we can recursively divide by 10, or we can just use string. Say n equals string of n, right? And then we are going to prepare the return. So this is very simple. Let's first use a dummy node. So I'm going to make it a list node. So here I'm going to use a value. Let's see, -1, right? It's just for convenience. And then we're going to set current equals dummy. And then what we're going to do is for the digit string or digit character in n, right? So what we're going to do is set current next to be the node, right, represented by this digit. So this integer d. And then we're going to set current equals current next, because we have already set current next. So this is legitimate. And then what we're going to do, we're going to return dummy next, right? So this provides one solution format. Actually, as we mentioned at the very beginning, so this problem is a classical one. So if we reverse the linked list to make the least significant digit as the height, and then we can directly add this, right? So with that said, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, basically that's about it for this specific problem. You're welcome to think up other solution formats or variants. Anyway, as long as we can solve this problem at a high level, so we can implement a number of different solution formats. So with that said, that's about it for this video. Thank you.